Hi, good day. So here are some examples of periodic motion. Example number one, an ultrasonic transducer or a kind of loudspeaker used for medical diagnosis oscillates at a frequency of 6.7 megahertz. Question, how much time does each oscillation take? And what is the angular frequency? So given is that the frequency of oscillation is equal to 6.7 megahertz. So given the frequency is 6.7 times 10 to the 6 hertz. Mega means 10 to the 6. So how much time does each oscillation take? That would be, you have to solve for the period, and period is equal to 1 over f. So this is 1 over 6.7 times 10 to the 6 hertz, and this is equal to 1.5 times 10 to the minus 7 seconds. So this will be the time. For the angular frequency is equal to 2 pi f. So we have 2 pi times 6.7 to the 6 hertz. So this is 4.2 times 10 to the 7. The unit is rad per second. So period is 1.5 times 10 to the minus 7, while angular frequency is 4.2 times 10 to the 7 rad per or radian per second. Okay, next example. We have a spring is mounted horizontally with its left end held stationary. By attaching a spring balance to the free end and pulling toward the right. So we have, by as shown in figure A, you pull the spring using this spring balance, and we determine that the stretching force is proportional to the displacement, and that force is given, which is equal to 6.0 Newton. And this 6.0 Newton causes a displacement of 0.03 meters. Then we remove the spring balance and attach a mass of 0.5 kilogram glider to the end, so as shown in figure B, and pull it a distance of 0.02 meters along frictionless air track. Then release it and watch it oscillate, as shown in this figure. Question, find the force constant of the spring. Letter B, find the angular frequency, the frequency, amplitude, and period of oscillation. Okay, first is we need to find the force constant of the spring. And force constant is denoted by K. So solution, we need to solve for K, and from Hooke's law, F is equal to Kx. And the negative sign is the direction of the force. So basically K is just the ratio of the force and the displacement x. And this F is given, this is 6.0 Newton, and the x, the force of 6.0 Newton causes a displacement x of equal to 0.03 meters. So therefore, K, the force constant, is equal to 6 divided 0.03 meters. That would be equal to 200. The unit is Newton per meter. So this is the force constant of the spring. Next, letter B, find the angular frequency. Find the frequency, the amplitude, and the period of oscillation. So we can solve for omega, the angular frequency. This is equal to square root of K over M, where M is given. M is equal to 0.50 kilograms, and K is 200 Newton per meter. So we have A is 200 Newton per meter divided by the mass, which is 0.50 kilograms. So therefore, omega is equal to 20. The unit is radian per second. Okay. Next, we can also solve for the frequency. Frequency is equal to omega over 2 pi, and omega is 20 rad per second divided by 2 pi. So therefore, frequency is equal to 3.2 hertz. Once we know the frequency, we can also solve for the period, because period is equal to 1 over f. So we have 1 over f. F is equal to 3.2 hertz. So therefore, the period is equal to 0.31 seconds. How about the amplitude? The amplitude is given. It says that when we remove the spring balance and attach a 0.5 kilogram glider to the end, and you pull it at a distance of 0.02 meters, it means that this 0.02 meters is the maximum displacement of your glider. And take note, the definition of amplitude is the maximum displacement of your body. So therefore, your amplitude is given, which is equal to 0.02 meters. Okay, another example. An object is undergoing simple harmonic motion with period of 0.30 seconds and amplitude of 6.0 centimeters. At time equals 0, the object is instantaneously at rest at x equals 6.0 centimeters. Calculate the time it takes the object to go from the initial position x equals 6.0 centimeters to x equals minus 1.50 centimeters. So the problem here is you need to solve for the time it takes to go from the initial position 6 centimeters to the final position minus 1.5 centimeters. So you need to solve for time. So in order to solve for time, we must know the expression of our displacement, and the displacement here is equal to x, which is equal to the amplitude cosine of omega t plus some phase angle phi. Given is that the initial conditions at time equals 0, the initial position is 6.0 centimeters and the initial velocity is equal to 0 meters per second, because the object is instantaneously at rest at time equals 0. So what we need is this A. Also, we need to solve for the phase angle. Omega can be solved from the expression of our period, which is equal to 0.30 seconds. Okay? So A is expressed as square root of x naught squared plus b naught squared over omega squared. And this is equal to square root of v naught is 0. So therefore, this is just equal to square root of x naught squared, and this is just equal to x naught. So therefore, amplitude is just equal to 6.0 centimeters. The phi is equal to tangent inverse of minus v naught over omega x naught. And we know that v naught is 0, so this one is 0, and tangent inverse of 0 is just equal to 0. So we know A, we also know phi. We can also solve for omega. omega is equal to 2 pi f, and f is equal to 1 over t, so this is equal to 2 pi over the period. Where period is given, it is equal to 0.30 seconds, so we have 2 pi over 0.30 seconds. So omega now is equal to 20 over 3. 20 over 3 pi. So the displacement will be expressed as a cosine omega t plus phi, where a is 6.0 centimeters, cosine the omega is 20 over 3 pi times time t, plus the phi, the phase angle, is equal to 0. So, when x is equal to negative 1.50 centimeters, so this is your final position, we can solve for time t. If we substitute this one here, so we have negative 1.5 centimeter equal to 6.0 centimeter cosine of 20 pi over 3 times t. So from here we can solve for time t, and this is equal to negative 1.5 centimeter over 6.0 centimeter cosine of 20 pi over 3 times t. So therefore, the 20 pi over 3 times t is equal to cosine inverse of minus 1.50 over 6.0. So therefore, time t, cross multiply the 20 pi over 3, so we have 3 over 20 pi cosine inverse of minus 1.5 over 6.0. And if you use calculator, you will get 0.0871 seconds. So this is the time it takes to go from initial position 6 centimeters to the final position minus 1.5 centimeters. We have to take note that if you use your calculator, you have to change it to rad. Okay? So the mode of your calculator must be in rad, not in degree. Okay? Not in degree. Okay? Okay, another example, consider a mass of 0.5 kilograms attached to a screen with K equals 200 Newton per meter. At time equals 0, the initial displacement is 0.015 and initial velocity is 0.40 meters per second. Question, find the period, amplitude, and the phase angle of the motion. And letter B, write equations for displacement, velocity, acceleration as function of time. So, first is we can solve for the period. This period is equal to 1 over frequency, and frequency is equal to omega over 2 pi, and omega is equal to square root of k over m. Once we solve for omega, we can solve for frequency, and we can also solve for period. So solving first omega, this is square root of k over m, where k is given, it is equal to 200 Newton per meter, and our mass is equal to 0.50 kilograms. So therefore omega is equal to 20 rad per second. So once we solve for omega, we can solve for frequency. This is equal to omega over 2 pi, and this is equal to 20 over 2 pi This is equal to 3.183 hertz. So therefore, from this, we can solve for period equal to 1 over f. So period now is equal to 0.31 seconds. So this will be the period. How about the amplitude? Amplitude is equal to square root of x naught square plus v naught square over omega square, where x naught is your initial position, which is given at time equals 0. The initial displacement is 0.015. So this is 0.015 meters, and the initial velocity is 0.40 meters per second. So therefore, A is equal to square root of 0.015 meters square plus 0.40 meters per second over omega, which is equal to 20 rad per second quantity square. And using calculator, you can solve for A. A is equal to 0.025 meters. So this is the amplitude. The phase angle can be solved by this tangent inverse of negative V naught over omega x naught. So phase angle is equal to tangent inverse of negative 0.40 meters per second. This is 20 rad per second. Your x naught is 0.015 meters. So the phi, or the phase angle, is equal to negative 53 degrees, or in terms of radian, this is equal to negative 0.93 rad or radian. So we have the phase angle equal to this, 53 degrees or negative 0.93 radian. So that's for letter A. For letter B, write equations for the displacement, velocity, acceleration as a function of time. So for letter B, x, the displacement as a function of time, is equal to A cosine omega plus t. So this is A is 0.025 cosine of omega, which is equal to 20 rad per second times time minus the phase angle equal to 0.93 radian. So this is my displacement. My velocity is equal to minus omega A sine of omega t plus phi. So we have negative 0.5 meters per second sine of 20 rad per second times time minus 0.93 rad. So this is my velocity, and my acceleration is equal to minus omega square x, and this is equal to minus 10 meters per second square cosine of 20 rad per second t minus 0.93 rad. So this is the displacement, the velocity, and the acceleration. Second to the last example, we have an object of mass 0.15 or 150 kilograms is undergoing simple harmonic motion with force constant K equals 300 Newton per meter. When the object is 0.012 meters from its equilibrium, meaning this is your x, when x is equal to 0.012 meters, it is observed to have a speed of 0.300 meters per second. Question is, what is the total energy of the object, what is the amplitude, and what is the maximum speed attained by the object? So for letter A, we need to solve for the total energy. And we know the expression of energy, it can be expressed as 1/2 kA squared. But take note, K is given, but the amplitude is not given, or amplitude is unknown. So we cannot use this equation. Instead, we can use the total energy as the sum of kinetic energy and the potential energy. So we can use this one. E is equal to 1/2 mv squared. This is the kinetic energy, and the potential energy is 1/2 kx squared. We can use this one because we have this given that when x is equal to 0.012, my v, or my speed, is 0.300 meters per second. So given the mass, which is 0.15, k is also given 300. When v is 0.300 meters per second, x is 0.012. So therefore, the total energy of the object is equal to this one. So we have 1/2 times 0.15 kilograms times the velocity, which is 0.300 meters per second squared, plus the potential 1/2 A, this is 300 Newton per meter, times x, which is 0.012 meters quantity squared. So therefore, using calculator, you can solve for the total energy, which is equal to 2.8 times 10 to the minus 2 joules. So this will be the total energy of the object. How about the amplitude? Letter B, we can solve for the amplitude now because E now is given, and this is equal to 1/2 kA squared. So from here, you can solve for A. This is equal to square root of 2E over K, where E is equal to 2.8 times 10 to the minus 2 joules. So therefore, the amplitude of the motion is equal to 2 times 2.8 times 10 to the minus 2 joules over K. This is equal to 300 Newton per meter. So therefore, A, using calculator, this is equal to 0.014 meters. So this is the amplitude of the motion. Last, we have the maximum speed attained by the object. To solve for the maximum speed attained when there is no potential energy. So therefore, E is equal to 1/2 mv squared, which is plus 1/2 kx squared. Maximum speed can be attained when the potential energy is 0. So therefore, E is equal to 1/2 mv squared, and from this, we can solve for the speed, which is equal to 2E over m. And we know E is 2.8 times 10 to the minus 2 joules over mass is 0.150 kilograms. So therefore, the maximum speed attained by the object is equal to 0.61 meters per second. So this will be the maximum speed attained by the object. For the last example, you pull a simple pendulum of 0.240 meters long to the side through an angle of 3.50 degrees and release it. Find omega, frequency, and period t. Okay, so omega is equal to this expression for a simple pendulum. It is just dependent on the length, not on the angle 3.50 degrees. So omega now is equal to G, which is equal to 9.8 meters per second over the L. L is given, which is equal to 0.240 meters. We have 0.240 meters, so therefore omega is equal to 6.39 rad per second. Next is frequency. Frequency is equal to 1 over 2 pi square root of G over L. It is also dependent on L, not on the angle 3.5 degrees. So we know this one, this is 6.39. So we have 6.39 over 2 pi. So frequency is equal to 1.017 hertz. And the period, which is equal to 1 over f, and this is equal to 1 over 1.017 hertz. So the period of this simple pendulum is 0.983 seconds. So this is the period, this is the frequency, and this is the omega 6.39 rad per second. So that will be all. Thank you.